In this problem, we are asked to determine the relative concentrations of these different species, given that we have 1 times 10 to the minus 4th molar solution of hypochlorous acid. Now, we can actually do an ICE chart for hypochlorous acid to actually determine the amount of every single one of these species except for water. But we can also use what we know about weak acids and the relationship between hydroxide and hydronium to figure this out. So we know that hypochlorous acid is a weak acid, and we know that because it's not a strong acid. And if we write out what a weak acid does when it dissolves in water, this is the balanced chemical equation. Because this is a weak acid, we know that the left-hand side of the equilibrium is favored, and so that means that the concentration of our hypochlorous acid is going to be greater than the concentration of our products. We also are going to assume that our concentration of hydronium is equal to our concentration of the conjugate base, or hypochlorite. All right, so already, without even doing any math, we know how to rank the hypochlorous acid with regard to the products in the dissociation. Now let me just say that when you go to rank these, Sapling will not let you rank these two as the same concentration. Even though when we use an ICE chart, we assume that they're the same concentration, hydronium actually has a slightly larger concentration because there is already 1 times 10 to the minus 7th molar hydronium in the water to begin with. So that would not make any difference in terms of significant figures, but in terms of ranking it for the purposes of getting through the homework, we have slightly more hydronium than the conjugate base. Now let's look at hydroxide. We know that the product of the concentration of hydronium times hydroxide has to equal Kw, or 1 times 10 to the minus 14th. So because we're dissolving a weak acid in water, our concentration of hydronium is going up, and therefore our concentration of hydroxide is going down. So therefore we know that our concentration of hydronium and our concentration of hypochlorite is greater than that of hydroxide. Now we have always assumed, so there it is right there, hydronium is greater than hydroxide based on this relationship. Now as I was saying, we always assume that the concentration of water is constant because it's so great. It's a pure substance. But let's just take a minute to look at actually calculating the concentration of water. We know that concentration is moles per liter. Oops, hold on one second. So if we look at how many moles are in 1 liter of water, well, 1 liter of water contains 1,000 milliliters, and because the density of water is approximately 1 gram per milliliter, that means that if I have 1,000 milliliters, I have approximately 1,000 grams. And so we can calculate how many moles are in 1,000 grams. So if we divide 1,000 grams by the molar mass of water, approximately 18 grams per moles, we end up with 56 moles. So the concentration of water is 56 molar, which is way greater than any of the other species. So when we are ranking these, of course water is going to come first, and throughout all of our aqueous reactions, water is always going to be water is always going to have a much greater concentration than any of the other species that are dissolved in it. So now we have our ranking. Water is the greatest, then comes our undissociated weak acid, then comes hydronium, then comes the conjugate base, and last but certainly not least is hydroxide.